Okay, this is our second video for the half angle identities, and it's going to look at how we're going to use the triangle problems to do the half angle. There's one tricky thing about using the triangle, so we're going to try to do it in two different steps to help with that tricky piece. So we're going to start with, again, triangle. If cosecant A is equal to negative 25 over 24, which we can reverse that and make it into sine, and pi is less than A is less than 3 pi over 2, we're going to find the three different half angles. We're going to do sine, cosine, and tangent. All right, now when we go to draw the triangle, A is going to be in quadrant 3. Just like we did with the angles, we have to determine the quadrant for A over 2. So we can do the right positive and negative for the outside of the square root. So our first step is going to be to determine that quadrant. And actually, I'm going to look at it as 1/2 A because it's going to make switching things over in the inequality a little easier. So we're taking our original inequality, and we're just going to cut everything in half. So we're going to do 1/2 times pi, 1/2 times A, and 1/2 times 3 pi over 2. And there's a reason why I went with a 1/2 as opposed to just dividing by 2, especially because a lot of times you have fractions in these inequalities. So it gives us this new inequality of pi over 2 is less than A over 2. And remember, A over 2 is that half angle, and that's going to tell us where the actual angle is falling, and this gives us 3 pi over 4. Now that's not an entire quadrant, so what you really want to think about with this is, here's pi over 2, here's pi. 3 pi over 4 is halfway in between. So really, our angle is somewhere, or A over 2 is somewhere in this space. Now if we're looking at what quadrant, it's in part of quadrant 2. So it's still going to be in quadrant 2. It's going that the positive and negative signs will apply for that. So it's part of that quadrant. And what is that going to determine for us? It's a small piece, but an important one. So it's going to be quadrant 2, which means sine of A over 2 is positive. And then cosine and tangent are negative in that quadrant. And that's going to be on the outside of the radical. Whatever we then get inside will be determined by the actual quadrant of A. All right, so once we've determined that information, and this is important that you use this later when we go to find the values, our second step is to draw our triangle for A. I'm going to do this on a new screen so that we can use it for our answers, but just keep this in mind, and you'll have this on the top of your notes page so that you can refer back to this also. All right, so our second step is to draw our triangle for A. This is the same thing that we did for our sum and difference and for the double angles. So we're going to put that in quadrant 3. And the reason is the original A was between pi and 3 pi over 2. Now it was cosecant of A equals negative 25 over 24. So I might just change that into sine is negative 24 over 25. And really we're just doing this triangle to find cosine. So we're going to do negative 24 here, 25 here. Find that missing side. That might mean doing a little Pythagorean theorem off to the side. And when you do that, you're going to get x is 7. Now because it's going to the left, it's going to be -7. Now in this case, we just want cosine of A. That shows up in all three identities. Cosine A is -7/25. This is all you need for the half angles. And usually I separate these from the other two in a triangle problem anyway. And our third step is just to actually answer the question. So for A, sine of A/2, we're going to write out the formula. And we know that sine is positive if you refer back to that up above in your notes, because A/2 is in the second quadrant. And just like before, we're going to replace the entire trig function with whatever ratio we came up with. There's a couple ways you can approach this next thing. Really, you have your calculator, so you could plug this all in and just keep it under the radical. If you wanted to do some simplifying steps, you could get rid of the denominator here by multiplying by 25/25. Oops. I just did a lot of work out there. If you're using your calculator, you use a fraction tool. The only thing I would say is make sure, in case the radical does not come out to nice values, which it doesn't always, just make sure that you put the inside stuff in, see what that comes out to, and then if they are perfect squares, then you can square root later on. And they're going to do the same thing for cosine and for tangent. Now remember, cosine and tangent are for A/2 are negative, and we decided that as our first step. So I'm just filling in, again, replacing the entire trig function with that ratio. I'm showing out some steps here, and then this is good also for someone that doesn't have the option of using the fraction tool. Now, if I wasn't asking you to do sine, cosine, and tangent, all three of them, you would have to do the tangent one out separately. So I'm going to show that. But technically, once you have sine and cosine, you could just divide those two out, and then it gives you your value that you need for tangent. But I'm just going to go back in and do one more time where we're plugging in everything. Tangent also negative because A/2 is in the second quadrant. I'm not going to show out all the simplifying work for this one just because we already did that twice, but you can. I kind of almost did. I showed a decent amount of the steps there, and then you get -4/3, which again, you could double check and make sure if you do your sine answer divided by your cosine answer, that also gives you that. So if you're only finding tangent of A/2, you would definitely have to do it this way. But if you had sine and cosine first, then you could divide those two answers to get your final answer. So that's really it for the triangles. Again, the key step here that messes people up, that's new for just the half angles, is deciding where that half angle quadrant is so you can do the correct positive or negatives for the outside.